Welcome to clickmyproject.com. Let me discuss about the project Energy Efficiency Pilot and Link Adaptation for Mobile User in TDD Multi-User MIMO Systems. Let me discuss about the abstract of the project. Over recent years, the even increased demand of high data rate transmission has led to a strong interest in multiple input, multiple output systems. The proposed MIMO is mainly used in uplink pilot and downlink data transmission adaptation approach to improve the energy efficiency of mobile users in time division duplexing of multi-users, multi-input and multi-output systems. The EE of users in a time division duplexing system where each user sends an uplink pilot sequence for channel estimation by the BS, assuring perfect reciprocity between uplink and downlink channels. Based on the estimate, the BS performs zero forcing beamforming and transmits data to users. The energy efficiency of different users can be decoupled because the downlink average throughput of each user is independent of the pilot powers of the other users, and energy efficiency design can be done on a performance basis. The E is defined as the average throughput per total energy consumed by the user, and find that the objective function is not quasi-concave in general. Performance evaluation of the proposed system can be compared with the existing system result. The better result can be shown in the way of the graph plot shown in the system of the MIMO TD system. In conventional mobile multimedia communication systems, many studies have been carried out based on the proposed system can improve the energy efficiency and the effective capacity of MIMO TD mobile multimedia communication systems. An energy efficiency model is proposed for MIMO TDD mobile multimedia communication system for multiple mobile users. The proposed uplink pilot and downlink adaptation algorithm has advantages on improving the energy efficiency and the effective capacity of MIMO TDD mobile multimedia communications. An energy efficiency model is first proposed for multiple input, multiple output can be implemented using beamforming structures. Let me discuss about the flow diagram for our process. First, capture the data from the dataset folder, and in the pre-processing folder, the input signal is used to voice signal. The voice signal information is converted to input data values. Thus, the data value converted into binary pattern and to given the process. Sample data to be given to the process, then to plot the sample data signal. Data preprocessing is a data mining technique that involves transferring raw data into an understandable format. Real world data is often incomplete, inconsistent, or lacking in certain behavior and is likely to contain many errors. Data cleaning. Data cleansed through processes such as filling in missing values, smoothing the noisy data, or resolving inconsistencies in the data. Data integration. Data with different representation are put together and conflicts within the data are resolved. Data transformation is a normalized, aggregated and generalized. Data reduction is the step aims to present a reduced representation of the data in the data warehouse. Next, in the TD signal, MIMO TD, then the input data to be encoding operation and the encoding data to be interleaving processes and to convert the binary to decimal conversion. Then apply to the QA modulation and then modulating data to add the cyclic extension and to generate the TD signal. Multiple input, multiple output wireless technology in combination with the time division multiplexing is an attractive air interference solution for next generation wireless local area networks, wireless metropolitan area networks, and also the fourth generation mobile cellular wireless systems. This article provides an overview of the basis of MIMO TDD technology, focuses on phase frequency signaling, receiver design, multi-user systems, and the hardware implementation aspects. Finally, The minimum number of transmit or receiver antennas has been placed. In this paper, time division multiplexing for MIMO channel is considered for wideband transmission to mitigate internal symbol interference and enhance system capacity. Next, in the uplink channel estimation has been proposed. The pilot distribution defined in the LTE specification, and we focus on the polynomial modeling to estimate the channel for all the TD symbols in a given resource block. In particular, a so-called double expansion modeling of the channel. This consists of applying the first order modeling during one TDD symbol duration and the second order modeling to approximate the channel variation between TDD symbols. We further analyze the structure of the channel matrix in the frequency domain. Next, in the downlink effective channel estimation has been proposed. The downlink estimation on known data from either the transmitter or the receiver, placing over all the subcarriers or just over some of them, which is the case used in the practice to reduce the overhead pilot symbol assisted modulation. Case of all pilots anyway is often used to simplify the treatment and to adopt this afterwards. This first approach, for instance, to produce the estimate also on the subchannels and don't carry pilots as to perform an interpolation over the whole bandwidth knowing only the pilot estimates. Finally, at the transmitter side, the downlink data transmissions are proposed. The receiver side and also the receiver side, then the transmitter the lowest path delay channel, and the receiver side the receivable process is also performed. Then the signal to be down modulated and to produce the received signal and to the received data. Sensitive in a receiver is normally taken as the minimum input signal required to produce a specified output min signal, having a specified signal to noise ratio and is defined as a minimum signal to noise ratio times the mean noise power. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right click the file and run for executing this process. This is the main window of the multi-user MIMO time division duplexing. By pressing the load signal button, we can browse the input signal from the dataset folder. And this is the frequency representation of our input signal, and this is the amplitude of our data points. By pressing the downlink estimation button, we can perform the downlink operation. This is the signal cancellation algorithm representation, and this is the subcarrier of our data points. Here we used 4 subcarrier. So this is the data points representation in every subcarriers, and this is the modulated signal by using the QA modulation, and this is the transmitted signal for every subcarrier, and this is the time division duplexing of our 4 transmitted signals. And this is the entire time division signal with amplitude representation. By pressing the uplink estimation, we can perform the uplink data transmission. Here the uplink data length is 64, and by pressing the receiver signal, we perform the reversal operation of our downlink transmission. This is the uplink estimation of our data points, and this is the time division duplexing signal through channel after performing the receiver plot. And by pressing the demodulated signal, we perform the demodulated of our signal. This is the demodulator at the receiver end for every subcarrier. This is our demodulated signal with representation of data points, and this is the SINR versus CDF graph. This signal interference noise ratio for modulated as transmitter is 2 and the transmitter for 4, and this is the signal interference to noise ratio for PK is 5 dB and 10 dB, and this is the optimal uplink pilot power downlink transmission rate for different users, that is for 2 users and also for 4 users, and this is the E of different users, that is energy efficiency of different users. For transmitter at 4 or 5, and this is the transmission rate versus power level graph, and this is the AC of the third users. For red line is the proposed system and blue line represents the existing system. The proposed OFM downlink for multiple used by time division duplexing multiple user for getting optimal energy efficiency. Thank you.